In this module, we shift from agents that reason to agents that act. Tool calling lets an AI work with APIs, databases, scripts, and services, while function execution turns intent into safe, validated, real-world action. So far, we've moved from reactive chatbots to goal-directed agents. Now the focus is action, how agents use tools, observe outcomes, and complete workflows. We'll unpack structured tool calling, the mechanism that turns reasoning into safe, executable function calls. A model on its own can explain, draft, and reason in language. The leap comes when an agent controller turns that reasoning into a controlled tool call. The agent might search the web, query a database, process a file, read a wallet, or interact with a smart contract. The important separation is decision versus execution. The model decides what should happen, the tool performs it, and the result feeds the next reasoning step. A tool schema is the agreement that keeps an agent from guessing. It tells the model which tool exists, what it does, which parameters it accepts, and what each value must look like. Types, required fields, constraints, and valid ranges all reduce malformed calls. The schema should also define the return shape, so the agent can interpret results and choose the next step reliably. Tool definitions are part of the agent's decision-making interface. A name like getWalletBalance tells the model what action is available. The description should add the conditions. Use this to retrieve a wallet balance with read-only access. It should also define what the tool must not do. Boundaries like does not submit transactions prevent dangerous assumptions. When tools overlap, the agent guesses. When intent is crisp, selection becomes reliable. Parameters are the contract between the agent and the tool. A good contract removes ambiguity. Define each input's type, mark what is required, and set boundaries like minimums, maximums, or allowed formats. When choices are limited, use enums instead of free text. Then validate both user input and model-generated arguments before the tool runs. Valid requests pass through predictably, while unsafe, incomplete, or nonsensical calls are rejected early. Once a tool runs, its return value becomes evidence for the agent's next decision. A vague response like done forces the model to guess. A structured response removes ambiguity. Success status, error details, amounts, units, network, identifiers, and timestamps. Keep it concise. The goal is not to return everything the tool knows, but to provide enough reliable context for the agent to reason, recover from errors, and act correctly. Tool use is a loop, not a single event. The agent starts with a goal, reasons about what it knows, and decides whether it can answer or needs outside help. If a tool is needed, it makes the call and treats the returned data as an observation. That observation changes the next reasoning step. The loop repeats until the task is complete, blocked, or should be escalated to another system or person. Selecting a tool is a decision process, not a guess. The agent first checks whether it can answer from existing context. If not, it compares the request with tool names, descriptions, schemas, and required parameters. System rules then shape the choice. Some tools may be required, optional, or blocked. A good agent also weighs cost, speed, risk, and permissions. When the request is unclear, the safest tool is clarification before taking action. In execution, the model suggests an action, but the trusted runtime performs it. The model emits a structured tool call, often JSON with a tool name and arguments. The runtime validates those arguments, checks permissions, and maps the tool name to a real API, service, or script. Only then does execution happen. The result returns as an observation, which the model can reason over, summarize, or use for the next step. The basic tool call loop is simple, but it needs discipline. Start by describing the tool clearly, its name, purpose, inputs, and required fields. Then bind that schema to the real function your code can execute. When the model requests a tool, parse the arguments, validate them, and only then run the function. Finally, return a structured observation, so the model can reason over the result and produce the final answer. Before any tool runs, treat validation as a safety gate. Check the request shape, required fields, types, formats, and ranges. Apply business limits. such as supported networks or maximum transaction amounts. Enforce permissions and required user confirmations. If anything fails, block the call and return a clear, actionable error. The goal is not only to reject bad requests, but to help the agent correct them safely. When a tool call fails, the agent should classify the failure before deciding what to do next. Timeouts, rate limits, and brief network issues are usually transient, so a bounded retry with backoff can make sense. Bad inputs, missing permissions, or expired credentials will not improve by repeating the call. In those cases, stop, return a clear error, or ask the user for help. If the primary service is down, switch to a fallback when available, then return the safest successful response. Here's a simple example. A user asks, "What's my USDC balance on base?" The agent should not guess or scrape text. It calls a typed balance tool with address, chain, and token. The runtime validates the address and network, queries an RPC or API, and returns structured data, amount, units, block number, and confirmations. If anything fails, the agent reports a safe, specific error. Tool calling turns an agent's reasoning into real action. Strong schemas make calls predictable. The execution loop lets the agent act, observe, and continue. Validation and error handling keep that process safe. Next, we build on this foundation with planning, memory, multi-step workflows, and agent safety.